one resistor. The triangular source can be generated using this source called V pulse. V pulse. So one copy of it goes here, and we need our ground. 1, 2, 3, 4, 5 pieces of ground. Now let's rotate it twice and flip it once to fix it. Next, negative power supply. Attach the ground, change the name to VS1, 15 volts, flip it, then attach the positive power supply, the ground, name goes like VS2, 15 volts, and flip it. Let's attach this guy. RL 10K. Okay, we're done with most of the items, but let's now see how to configure that. So I need to draw something somewhere. Okay, please pay attention. So we're basically trying to generate this triangle, okay? And I'm gonna change the shape. Okay, forget that. You need to create this, one copy of this. Excuse me, you people, please do not talk. How to create that using VPulse? There are 7 parameters in VPulse. V1, 2, TD, TR, TF, PW, PR. 7 parameters. How to fix them? Well, let's start with these voltages. These are 2 boundaries, okay? You cannot get out of those, beyond those limits, okay? Limits. Usually, V1 is a little bit less than V2. V1 less than V2. Less, more. Lower limit, upper limit. Like that, okay? So this is their relation, and you start with V1, not V2 at first in the graph, okay? So these are some points to keep in mind about V1 and V2. What are those? Only 2. V1 less V2. Okay, these are boundaries. V1 less V2, and you start with V1. 3 points to keep in mind. Try to do that over there. Try to do that over here. Try to find out that thing over here. Do you see any boundary with the triangle? Any boundary? Definitely there is a boundary. Can't get more than 5, can't get less than 5, minus 5. So these are boundaries, 5 and minus 5. Okay? Then, if 5 and minus 5 are the boundaries, which one to choose? 5 or minus 5 here? And what about that? That's the question. Okay. V1 was like, you start with V1. What do you start with?
0.
You start with V1.
0.
You start with 0. But is 0 a boundary? No. So a problem. That means boundary is 5 or minus 5, and you are supposed to start with one of those. With either start here or start there. Okay? So if I say that I'm gonna start with minus 5, if I say I'm gonna start with minus 5 and change the figure a little bit, then is it the same as that?
No, sir.
Why no?
Because 1 has
Is it the same as that?
Because 1 has been moved away.
Yeah, that's it. But if I do something like this, then it was like this, and you move it onto the right a little bit, then you're gonna get something like that. So basically, although there's a little bit different, but the waveform is just the same. This is not a different waveform, the same waveform. Okay? So you need to fix it in order to just get it done within these boundaries, within these VPulse, within these rules. Okay? You need to keep this guy enclosed into those rules in order to get it done by the software. That's it, simply. Okay? So you make the change. Okay? No change in waveform, so you can work with it. Now, what can you see? What do you start with? Minus 5 or 5? Minus 5. So what should be the value of V1? Minus 5. Then what should be the value of V2? The other one, 5. Done. Simple. So this is how you do it. This is how you choose it. Then, TD. TD is the time you spend with V1 at the beginning. Okay? Told you you need to start with 5. You need to start with V1 and then spend some time with it. Okay? Stay at V1 using some time. Okay? So that time is going to be TD. Are you spending any time at all over here with V1 minus 5? No. That means it should be 0. TR means, well, started with V1, spent that amount of time with V1, now it's done, so go to V2 linearly. And that time is known as TR, rise time. Okay? So this is V1, that is V2, I'm done with V1, I'm gonna go to V2 linearly. How much time am I taking over here? How much time? These are all milliseconds, and these are all voltages, by the way. Okay? How many milliseconds? 1 milli. That means done. Next, TF. Done with V2, you get to V1 linearly using some time. That is TF. What is that? From V2 to V1, 1 millisecond again. Now, what is PW? Well, the time you spend with V2. Okay? The time for this guy was TD, and the time for V2 is PW. How much time are you spending with V2 once you got there? Looks like 0. I didn't spend any time, but there's a problem. If you select it to be 0, the software is not gonna take it. Okay? The software is gonna replace your 0 with a default value, which is not gonna serve your purpose. So you need to put something else. That means what's the deal? You need to put 0, but cannot put 0. So try to put something which is very close to 0. Very, very close to 0. Okay? That means you need to go for a very smaller value. You are operating in milliseconds, so that value should be smaller compared to milliseconds. You cannot use 1 second. 1 second is small, fine, but not applicable here. 1 millisecond also small, not applicable here. You should go for something less than millisecond. Okay? For example, 1 microsecond is just enough, quite smaller with respect to milliseconds. I'm gonna choose 1 microsecond, and this is, by the way, not equal to 0, so it's gonna accept it. Okay? What is PER? It's a period. What's the period over here? What's the period? So this structure is going to be repeated. What's the time of the structure? 2 milliseconds. That means it is 2. So that's how you set it up. Okay? So let's do that. P1 minus 5 volts, P2 5 volts, TD 0 second, TR 1 millisecond, TF 1 millisecond as well, PW 1 microsecond, and PR 2 milliseconds. Yeah? U. Mu is not possible. Three letter mu. That's why U. Smaller U. Okay, you configured 7 parameters, but those are not visible here. Make them visible.
PW plus 2 microsecond and 2 milliseconds.
So all are overlapping there, all those 7 parameters, you just separate them.
Microsecond দিতে হবে 0 সেকেন্ড দেখাবে মাইক্রোসেকেন্ডে
Okay, so done with the circuit. Now transient or whatever. Well, I think I can skip that part. Transient analysis is up to you. You know how to configure that. Attaching those, I mean, you need this information, how to get it using markers, up to you. You know how to do that. So saving, simulating, you can do that. Getting the graph and attaching all these labels, yeah, up to you. You can do that. Okay? You'll get, just make sure you get something similar to that. If you get this as an output, there, you're done. Everything is done. Everything is fine. Okay? So, you complete it that way, and then complete this one as well. from here? Did you take the note, all of you? I don't think so. If you haven't taken the note, please take 2 new circuits, inverting positive voltage level detector and non-inverting, corresponding non-inverting structure. Look at this. What's the difference between the 0 and positive? Previously it was 0. Now this is no longer 0. This is the nodal voltage, and check. Plus, plus, minus, minus. The value of this guy is 2 volts now. This is a DC voltage. Okay? So inverting positive. What does it? And by the way, triangle is here. Inverting is gonna get the unknown guy. Inverting triangle. Positive voltage. This is the known guy to the other terminal. That means positive. Non-inverting input terminal is gonna get something positive. What is the nodal voltage? Something positive. So that's the interpretation. And by the way,